All right, let's get started. Welcome to the stream, to the Twitch viewers out there. I appreciate you hanging out with me this afternoon on a Sunday. Even though at least where I am, the weather's pretty decent. It's sunny and it's a little bit warmer outside. Let me see exactly how warm it is. How warm does my phone say it is? It's 44 degrees out there. It's sunny. It's a nice day. A lot of that snow is going to melt, and my driveway is going to be nice and clear because of it. To my YouTube viewers, or our YouTube viewers rather, thanks for joining us, and we really appreciate you checking out another video in our series. Today we're going to continue on getting more of the programming done for the example, the core example that's going to ship with the board, and to also work with the test fixture to do the cycle counting to test this TPU belt. Again, this is a basically solve two problems with one blackboard approach. We're sussing out some, example firmware that's going to ship with the board. Basically give you an idea how to use it, how the subsystems that you can incorporate in your other projects for the fan and other things. And then again, the test fixture that's going to just do a cycle count on the TPU belt and see how long it lasts, before it stops working, before it breaks. So yesterday we ran into a problem and I think I figured it out. So let's go to my main screen here. So I realized that I had, for the write function, it was set to read only. Yeah, it will, and I think that's what was causing the system to error out. So let's build this. Let me make sure the system is in program mode. Yeah. So, yeah, what it was doing is yesterday it was like the program was hanging up. Probably because it couldn't write to the flash memory. Because based on our init, so when we initialize, we initialize the flash. That way, if no flash section exists, it kind of cleans it up, gives it there, initializes it, and then it does a read because we want to pull the cycle count right off the bat. That way any value that's stored in there gets loaded up and we can continue our count from there. Then it creates the task, which will basically just look at the cycle count when it equals itself plus 10. It'll go ahead and write the cycle count back to memory. That way we avoid, we limit the number of write cycles, because we've got about 10,000 write cycles on the non-volatile memory on this guy. And this will slow down this consumption of that. So here's the read function. It'll read. Here's an error handler. We'll do that with the flag. So if it can't find it can't open the memory and find the tag for it, basically called storage, it won't. So then here it gets the 32-bit cycle counter during this read, so it'll get it. And if there's a problem, like say the cycles, basically where the key value doesn't exist, which means the data won't exist. So basically for a fresh flash, a fresh chip, it'll go ahead and write the cycle count at 0, because it should be initialized at 0 all the way over here. So it'll get initialized. Yeah, cycle count gets initialized at 0 right off the bat. It goes through a thing, initializes again, wakes up the NVS system, and then it reads it. And then everything happens so fast before you even, an operator would have a chance to do anything. And then it would write it. So hopefully this works. So we've got this guy So let's get the camera going on my phone. Right, and boom. And let's see if this solves the problem together. Oh, let's go over here to the phone. Refresh it. Boom. All right. So we flashed it. All right. So that did solve it. It does move. Let's go over to the RS-45 interface. I'm going to speed up the motor. All right. So we're going to go back to the display because we're going to watch the terminal. So since we effectively just have 0 counts, it flashed. So it basically, when it goes to the cycle, when it goes to the limit switch number 1, it should basically set a count of 1. Okay, so count 1. Okay, so what we're going to do is we're going to let it get like 2, 3. Okay, so let it get to 3. I'm going to reset the board. Okay. All right. And then let's just see if it starts back at 1, which it should. All right, 1. Now we're going to let it get at least 11. I'm hoping this works. All right. So the good thing is at the end of the day, we'll get a total cycle count, hopefully, of, plus, potentially minus 10. That'll be our error factor. That's 10 counts. So we'll stop it. I'll re-enable it. I'll reset the device. We're going to reset the motor speed. It should actually start at 11. Okay, so now we have a problem. It's not. Why is it not reading? Okay, so now we have our first issue. Why is it not setting? Maybe that's right. Now, for some, what we're going to do, we're going to give ourselves a little bit, copy this, only because what we're going to do is we're going to kind of, this way, what we can do is that, come over here. Well, let's just copy this. Come back here. I'm gonna throw it in here. Just basically some debugging code. All right. So what this should be able to do is let us know that it's actually trying to write. Okay. Write this. Go. It's a little bit of debugging code. Reset. Okay, so the task isn't working or something. NVS system task. If so, well, one. Okay. What we got here? The task code. What in the world is wrong with you? Okay, so the logic, something's wrong with the logic. Okay, let's think about that. No, that will never work. Okay, okay, that'll never work. It will never hit that value. All right. So, actually, cycles aren't being used. Cycles. All right. Let's go to prior. Okay, that's why it will never work. Okay, why? If okay. Count. Prior cycles. All right. So for prior cycles, so we need a kind of a variable to hold that. I have something to compare to. Well, that should do it. Okay, so all right. Still didn't do it. So let's see. Maybe it's just not sending. No. All right. Logic is still broken. So what is wrong with you? Where are you broken? All right. Why are you broken? this. System task. Let's do something here. Nope. Don't need that. So it's going to be a lot of that, but I'm fine. I just want to make sure the task is actually starting up. So if the task isn't starting up, wait a minute. Am I actually initting? Did I actually? I'd be dumb if I'm not initting the. Oh my god. Well, now I may not have solved the problem. We will figure it out. Oh wow. Okay, that was dumb. All right. Well, let's try building it again. We're not even going through the we're not even initting. This is the NVS system, so we may not have solved it. I'm hoping that's what did it. The read write that was just stuck. All right. So let's reset. No, okay. All right. I didn't fix it. Oh my gosh. All right. Oh no. Where are you? Why are you breaking down? Let's go here. Why in the world are you not working? Can we monitor? Can we see any kind of failure? No, it's not. Okay, flash and net. All right. Do we have to do anything to initialize the NVS? I mean, it's acting like it's there. NVS. Oh. All right. All right. All right. Let's see if I can get a different answer. All right, let's see here. All right, I'm really tired of all the examples being around Arduino. All right. All right, so there's nothing there. Let's see if that gets mad. It might not like that. Rebuilding for something. Oh boy. Annoying. I was hoping that maybe I need to. Maybe this has to be read write as well. Figure if we're just reading. It wouldn't matter. Oh, you know what? Might be doing it too. All right. That might have been doing it. Oh. Oh. I was hoping to get this done. Okay, it's resetting constantly for some reason. That's kind of good. It's a behavior that I didn't expect. Let's see what she's mad at. All right, all right, all right, all right. This is kind of good. Turn this off. So, what are you mad at? Exception was handled. All right. I bet you it's mad at. I'm hoping. I might be mad at that. Oh. Maybe. I mean, we got it to do something different, and that is important. Let's flash that over. Well, let's go over to this guy. Okay. Okay. So it's not in a reset loop anymore. Still not getting anything out of it. You know, let's... Yeah, it's still hung up. Where in the world are you upset at? Why are you upset? Stop being mad. All right, so how are we going to do this and troubleshoot this? So it's almost like it's not getting past this for some reason. So I know what we're going to do. We're going to grab this. We're going to make it, we're going to make our code a little bit messy for now. Right. Error. Let's see here. I don't know if that's going to be a long. It'll complain if it's not. It's just a U. Boop. All right. Okay. What we want to do is we want to see what if there's an error code, it kicks out of there, and I might try to figure out what the error code is. and then debug it off of that. Flash init error 0. So there is no error. Okay. So there is no error. So it seems like it inits the flash. Because I think 0 means it's okay. All right. So NVS read. We need NVS error. NVS open. It's just you. Right. Oh. Okay, let's flash you. Here, so that should be read. So it's not ESP. Okay. So 0 means if it doesn't mean okay, so it should go down here. Okay. NVS get I32. 32. Pain in the rear, but I'm trying to go through and logically figure out where you're failing. Right. Okay, so we have an error. Okay, error number 2. All right. Crossed area cannot be found or namespace exists yet, and mode is NDS read only. Wait a minute. Let's see here. Go to declaration. I want to know what the error is for that. Okay, error NVS not found. Okay. Making progress. NVS open error. For right. So it should come down here. So it should close that. And go to the right where it opens it. Errors here. That's to be expected. NDS not found. X02. So it should. So that might not be the error. So, you know what? What? Case 2. That would be 0. Maybe it's having trouble translating that. All right. Well, let's see what. Because it could be having trouble translating. I don't know. Okay. Open error for right. Okay, so it got past that. So it should have written it. Okay. All right. Now let's reset. So now it's there. Okay. All right. So yeah, it was having trouble with the cases. With how it for some reason it couldn't process the error. Let's just go ahead and put that because we know the ESPOK is going to be 0. So it should have written zero because we know it returns a zero if it's find. It's fine. Let's do error equals. I don't know if it's so. Why isn't the motor moving? Okay, we've got something. We're getting slowly past all this. So it so get I-32, so it does get it. And so let's go ahead. Nope. So that should get the cycle count. I mean, making progress, but the motor's not going, so something else is up. So it apparently is reading the cycle count. Okay, maybe it's stuck here because that's a possibility. Oh, because if we can get past this, we can clean all this stuff up and then start figuring out how we're going to wrap everything up in the RS-45. Because we want it to kind of be the other way around, to where this holds the data and we incorporate it in the RS-45, and then we grab the data and we can do different functions and tasks. All right, let's go to the RS-45 before I reset. See what she's gonna do. Boom. All right, now let's see. Still not doing anything. Why are you stuck? Where are you stuck at? Are we actually tasking? Oh, come on. Task. Operating. All right. Okay, let's flash you. Are we getting to the task? Is the task causing the problem? All right, let's enable. We are in the task. I mean, the task is operating, so... Why haven't you... Is open. So... Why aren't you moving the stepper motor? Let's disable that loop here. All right. So I know something up. So it's in... It's constantly resetting. Why are you resetting? Let's see here. And it should not return. Okay. Mm-hmm. Wait a minute here. This is some task. So yes, I'm going to return. All right. There's no... You know what? Let's get rid of the task. Let's... Let's get rid of the task here. Let's just give it no task. That's fine. Let's see what that does. I think we still need a task. Flash it. Let's see what she does. In some ways, I don't. No. Why are you not working? Okay. Let's go and put the task back in there. Okay. Stuff. All right. Maybe it needs to pretend it's got something coming in. I don't know. I want you to work. Slowly making progress. Slowly. Why are you hanging up? Why in the world are you doing this? Oh. Let me see here. ESP32. RTOS. Free RTOS. RTOS. Let's see, we understand how. Wait a minute. Wait a minute. Okay. E5. There's no task, I don't think. All right. See if maybe I don't have the task scheduler running. Okay, we got it's actually running. Let's see if all right. So we got something different. Okay. So it was doing something different. All right. This is good. This is good. But the rest of the system stopped working. Okay. All right. So sometimes I'll take question. This is when. This one's just starting the kernel. So the task start scheduler. So we are getting somewhere. Start scheduler. Where? Okay, do not call it. Okay. So it says do not call it on the ESP32. Because it's already called, which is kind of weird. Okay. All right. Okay. Let's see here. Maybe it's a ESP32 non-Arduino using of components. Can you do that? Sensor task. Oh, wait here. Oh, okay. Wait a minute. Void. On in the system task. Right. Okay. Oh. Okay. All right. Do this. Okay, the task is operating. All right. Okay. Why isn't that working here? Sensor task. Oh, no, wait a minute. Nope. We'll need that there. I need to. Sensor task start. So it's acting like it's operating. Okay, to never return, so that should be doing that. It should return. Okay. Right. Okay, let me see if I can fix this. Okay, so that's hash, that's the handle. Oh, that's 2048. No. Let's go ahead and give that 5. I just don't. Maybe too many of them are sharing the same priority. I don't know. Right. So we got the task. I mean, we're going into the task. Just, why isn't the motor operating? All right. So ESP32. Thirty-two. All right. So it's basically seems like it's crashing out of here for some reason. Maybe that's why we can't. Why aren't you working? All right, so you're. It's like it's not. Okay. We. Okay. So it's tasking. Okay, so the tick. Okay, it's in the task. Okay. All right. So we know we're inside. It's ticking in here. Maybe. Wait a minute. Task create. Maybe we need to use. Right. How many? So we know we're inside, and technically it's not going to return. It's just it doesn't return anything. It's just going to. If this happens, so why aren't we? Okay, so we have the task. Okay. Let's get rid of some of that fancy stuff there. Okay. Now, let's just shorten that. Let's make it a little bit sweeter. It might be a little too long. Who knows? Because it did say 15 characters max. Okay. Getting into the task. That task is starting, but it's not letting like anything else work. Okay. Okay, so the RS-45 is working. Those tasks are fine. So it comes here. Init. Wait a minute. Is the status? You know what? Let's go ahead. Okay, so the two tasks that are defined are working. Operating. Oh, okay. But it won't allow us to use the main. Right. Oh. Okay. Yeah, so let's just be a void. All right. This is getting annoying. Yay. All right. Here we go. Yeah. Yeah. R35 helps. Let's see here. Let's see here. Call X. Let's just do that. It just sits in that loop. could be puking its guts out for some reason. Our logic could be breaking it. No, the envious task. For some reason, that as a task is gumming up the whole works. So let's just do one thing here. All in it's done. Initialized. Let's see if it's getting down here. Let's see if it's getting past all this, and then we'll see if it even if it gets into the control loop, the while loop, the main while loop. I don't know what the hell's going on. We may have to create this as a task too. Oh. I don't know. Okay. All system functions initialized. So maybe we need a let's create it as a task. What the hell? It's not gonna hurt anything. Void motor. Operational task. Now what we're going to do is right. What is it called? Operational task. Operate. Oh. And then operational task. Come down here. Now let's see what happens there. Let's actually create a task out of it. And if this works, if this solves our main problem, See what happens. Know what we can do. All right. Oh, okay. All right. Well, give you. Operational. Main operation loop. All right. Right, let's skip that. Already have 2. All right. If this doesn't work, we'll end the video. We'll end the stream because we're definitely a little over an hour and a half. And before I get too frustrated, I start punching my screens. So we should go into the main operating loop. All right. So we're not. Are there too many tasks going on? Many tasks. Main goes here. Okay. Oh, wait a minute here. Just returns unexpectedly. Maybe it shouldn't be a task. All right. Well, we're going to end the video here. I mean, the ESP32 is not puking its guts out. It's perfectly content with. It's completely content. It's just not getting here. You know what? You know what? Okay, I lied. Let's try one more thing. Maybe not having any kind of delay is not letting the system kind of do its own thing. Oh, and we have motion. All right, all right, all right. Just by giving. Okay, 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 okay. Let's see if we can get this to work. All right. Okay. Okay, so apparently it wrote the cycle count. Okay. I think we just didn't give the CPU a chance to do anything. I think we were just hogging all the CPU time right here, and we just gave it a little bit of, 100 milliseconds. Just enough for it to breathe. Enough for it to breathe. And I think that might have solved it. So let's see here. So now we did that. So we're going to reset. Cycle count is 10. Oh. Okay. All right. All right. So now it should get up to 11. 11. Okay. Now that's 20. Now we're going to reset it. Yeah, it's going to be messy because of everything, and that's fine. I'll get rid of a lot of this prints and stuff down the road here. All right, at 40 doesn't matter, so we're going to enable, and the cycle should start at 21. Oh, okay. So we got it. Okay, that's what it was. All right. We didn't. So in this task, it was just constantly running over this and just not giving the system any time to do anything else. It was just hogging the whole CPU's time. So the reason the RS-45 works is it only does something when data's on the RS-45. When there's something there. So it's not really borrowing the time. It's if the buffer, yeah. Okay. All right. plus there's delays and stuff. All right. Okay. All right. So we got that. Okay. Oh. So now we've got it saving. Now I'm going to power the unit down. So the cycle count should start back at 20 when it. All right. 21. All right. So it maintains the memory through a power cycle, through resets and power cycles. Okay. So we solved that problem. Woo. Okay. I am so happy. Oh, that's one big headache out of the way. So that was a positive. We'll end the video here on a positive note. And then we'll work on coding more of this, cleaning all this up, get all those stupid prints out of there to clean up the RS-45 interface and do it right. Put all the things in here so we can put commands to reset it back to 0, to get the cycle count via RS-45. And we might even be able to use the RS-45 to force a cycle right, maybe. Because the logic would still work if it's plus 10. So like if you're at, like say your cycle counts at 21, plus 10 would be 31. So the logic would still work. It wouldn't be an even 10. So that's fine. So again, thanks for hanging out with me. We really appreciate it. I really appreciate it. And we'll catch you tomorrow evening as long as things go right and I'm not too tired from work. Take care. Have a nice rest of your day.